Hi, I'm doing this video to help you find the average rate of change of a function. Average rate of change is just really the slope. So, and that's what they're really asking you to do when they ask to find the rate of change over a certain interval. So you just have to recall how you find a slope of like a regular line. Recall that if I have 2 points, like my first point is 1, 2, and my second point is 3, 6. If I want to find the slope between those 2 points, then I use the slope formula, which is y2 minus y1 over x2 minus x1. And so this is my x. I can call this for my first point, and then that's my second point. And then I would plug in the y2 in place of this formula. And then the y1 would be a 2, and then x2 would be the 3, and x1 would be the 1. And then we would calculate this. 6 minus 2 is 4, and then 3 minus 1 is 2, and then we simplify, and our slope would be 2. Okay, so we're still doing that same process. There's just a few pre-steps that we have to do before we are able to straight do this exact process, okay, with this problem. And I'm showing you an example of just a straight line and 2 points on a straight line. A straight line has a continuous same, no matter between 2 points, no matter which 2 points you choose, it has the same continuous slant, a slope. With a function like the one you're given here, the difference is that we are erase this real quickly. This is going to be something that looks kind of like this. And so what we're going to do, they're going to give us 2 x values, which they have, this one and this expression for the x value. And then we just have to find the slope between those 2. But in reality, in a function like the one given here, the slope, that slant, is changing depending on the 2 different points that you choose. Like you choose these 2 points, and it's going to get a steeper slope. If you choose those 2 points, that it's between that point slope. So they just say, hey, what is it? When they say average, they're kind of thinking, what is a good number that might be close to the slope of between those 2 points, right, of the graph. So that's why they're saying average here. It's not exact because the slope is changing a lot between those 2 points. But if we want to give them the average, we just find the slope as if the function was a straight line between those 2 points. Okay. So the big thing here, these are x values. This is our x1 and our x2, like we saw a minute ago in our problem. We need to calculate, we need the y1 minus y2 over x2 minus x1. Well, we already have part of that problem. Our x2 is 6 plus h. And we can put it in parentheses. And then our x1 is 6. And so the only things that we don't have here are the y2 and y1. And how do we find that? We find that by plugging our x values into the function and simplifying and seeing whatever we get. Okay. So let's do that. I just have to plug in 6 because I have And this is very similar to a long time ago when you did a table, right? And you pick an X value and you plug it into the function and find out what the corresponding Y coordinate is. That's what we're going to do here. I'm going to plug into the function 6, and I'll write my work right here. 1 over 6 plus 11, that simplifies to be 1 over 17, right? Because 6 plus 11 is 17, so 1 over 17. So the Y2 value, so when this is my X, what I'm calling X1. So when X1, my X1, Y1 is 6 is my X1 and Y1 is the 1 over 17. Okay, so I get to plug in now up here for the Y1, I'm going to plug in 1 over 17. And then now I have to find a value for 6 plus H. So this is kind of a weird concept and idea, but I can plug in an expression for where we were used to plugging in just a single number. I can plug in an expression, and actually, I mean H here, but there's nothing wrong with that. So I have to be very careful. Exactly where I see the X, instead of putting a number, I put an entire expression. The 6 plus H will replace the X in every single occurrence of the X in the equation. So that's what I'm going to basically get. I'm going to get 1 plus 6 plus H plus 11. And then this is going to simplify to be, well, now I just combine like terms in this denominator, 6 plus H plus 11, which gives me 1 over H plus 17. So I plug in 6 plus H, that is my X coordinate, and that was my X2. Then the corresponding Y coordinate I got was 1 plus H over 17. So for my Y2, so that's my X2, Y2, for my Y2, I plug in 1 over H plus 17. And now I just subtract everything and simplify, this is kind of the hard part. I have to be really good at math and really good at adding and subtracting fractions and all that to get this down correctly. So, and that's why in this class, we took our time reviewing all the operations of fractions. And I hope all of you truly actually did review those chapters and learn them well, because we're going to need them here. Okay. So in the numerator, I have 1 minus H plus 17, or 1 over H plus 17 minus 1 over 17, okay? And then in the denominator, I have, the denominator is pretty easy. I just have 6, and I can drop the parentheses here, right? It's just 6 plus H minus 6, which equals H. All right, I have 6 plus H minus 6, well, the 6's cancel, and I just get H, right, on the bottom. Okay, the numerator is a lot harder, and let me just write it out. It's just 1 over H plus 17 minus 1 over 17. So this is what I want to do to kind of simplify this is to add these fractions together, and then I can hopefully make this look a little better. So this is going to kind of be a lot of work adding these fractions together, but it's not too bad. Now, just like when I was adding like 1/2 or minus, let's say 1/2 minus 1/3, we need to find a common denominator. And if they were prime numbers, then what you could do to find a common denominator is just multiplying those primes together, and that would be your common denominator. And that's what's going to happen here. Anytime you have like something that cannot be factored, as like h plus 17, that can't be factored in the sense that with all that factoring that we were practicing in those previous chapters, can I factor a greatest common factor of this? No. Can I factor this by saying this is two binomials multiplied by this? No. Can I factor this by saying, is this a difference of squares where I know I can factor it? No, there's no way I can factor h plus 17. They have no greatest common factor, and there's no known, X method, AC method, no, nothing will factor this. So this is pretty much just like 2 is a prime. Algebraically, this is a prime. And 17 is not even, that is a prime as well. So we need to find the least common multiple of those. We can just multiply them together. So our common denominator there is going to be the expression h plus 17 times 17. That just like we did 2 times 3 and found a common denominator because they were both primes, I would do h plus 17 times 17. That's my common denominator. And so to clearly do this, I'm going to do the 1 over h plus 17, and I'm going to multiply by 8 by the 17 on numerator and the numerator and denominator to create fractions that have the same denominator. So 17 over and I'll just multiply that out. That's 17h plus 17 times 17. Well, I can say 17 squared, or what is that? I'll just calculate it. 17 times 17, 49, and then 11, 7, 1. Right? 7 and 1. Okay. Then we add them 9, 8, 2, 289. Okay. So that was this first fraction, and I built it up to have a common denominator. Now I take the second fraction, and I am subtracting this one, but I'm writing this horizontal problem vertically, as you see. And I'm going to multiply that one by the opposite denominator, the h plus 17. And then I get the same denominator, the 17h plus 289. And in the numerator, 1 times anything is just that thing, so h plus 17. But I am going to put, so I'm going to erase it and put what we have down here. Now I'm actually going to subtract these expressions, right? I built equivalent fractions, the two that I was trying to subtract, and now I'm going to not. The mistake students make here is they try to start simplifying. But is there 17 in the numerator and denominator? Yeah, but we built it so it would look like this. So we're not simplifying yet. We have to subtract. So I do 17. Do the numerator here minus the denominator here. I have to be careful and make sure that it's put in parentheses because I'm subtracting everything there. So I have to really distribute a negative to everything in parentheses here. So it's kind of better for me to write this out. So 17 minus h plus 17 all over the 17 h plus 289. I have to make sure and I have to distribute the negative sign. That's a common error that students make. So then the 17, positive 17, minus 17, they cancel and I just get negative h in the numerator over 17h plus 289. But all of this was just in the numerator of our original problem, right? So I'm going to erase this, and I now subtracted the fractions. Now I have them, the answer to that is this, the negative h over was it 17h plus 289, and all of this is over h. Okay, so now I have to divide these two. Not quite done yet, right? So I do the negative h over 17h plus 289 divided by h, but anytime I have a whole expression like that, I just put h over 1. So I have to remember this keep, flip, change. So I keep this first expression the same. And then I multiply by the reciprocal. I like to write arrows because it reminds me that I'm about to do each step, but I write an arrow here that keep that one the same, flip this one, and change this division to multiplication. Now when I'm multiplying here, now only when you're multiplying fractions, you can cross cancel here. And I'm going to get negative 1 over 17h plus 289. And that's my final answer. Simplified as can be, I would have to make sure that there's no common number to the denominator and numerator, because the numerator is -1. Like, we don't have to worry about that, but let's check. I'm going to check my answer. That's exactly it. You can write this in a few different ways. You know, like if you were to write negative, just put the negative in front of the fraction. That would be the same answer, right? I think that's how it's 289. That's how they have it written, okay? Anyways, it's a very, very long process, but all it is adding fractions, multiplying. It's adding fractions and it's dividing fractions, and they're each individually, when you break them down, they're not hard steps. It's just a lot of steps. All right. I hope you enjoyed this video, and I hope this helped you. Bye.